Now let's look at some asymptotes. An asymptote is simply a straight line that a function approaches but never touches. So from our four basic functions, the functions that do have asymptotes are firstly the hyperbola. It's got a vertical asymptote over here, and it's got a horizontal asymptote over here. So as you can see, the function goes up and approaches this line, but it never touches it. And same here, it goes all the way closer and closer to the horizontal asymptote, but it never touches it. And then also the exponential function has gotten a horizontal asymptote over here as it approaches the asymptote but never touches it. Now for this question, it says write down the equations of the horizontal and vertical asymptote. So we see that this point where the asymptotes intersect each other is at -2 and 3. So for the y value, the asymptote intersects the y-intercept or the y-axis at 3, and that means since an asymptote is always parallel to the x, or this one is parallel to the x-axis and this one is parallel to the y-axis, it means the equation of this asymptote is simply going to be, so that's the horizontal asymptote. And for the horizontal one, the equation is simply y equals to 3. And then for the vertical asymptote, since we have -2 over here, the x-intercept here is -2, then the vertical asymptote is x equals to -2. So over here, write down the equations of the horizontal and vertical asymptotes. We have -3 for x value. That means we have this -3 over here. So our vertical asymptote, the vertical asymptote is, the equation is x is equal to -3, and the horizontal is here at -1. So it goes through -1, so the equation there is simply y equals to -1. And now write down the equation of the asymptote of the following graph. So this is now an exponential graph, and we can see that this line, our dotted line, goes through 2. So simply y is equal to 2. That's simply the equation for that asymptote. And now we have this one, where we see the asymptote is simply at -3, so y is equal to -3.